So we can still connect capacitors in series and parallel, just like any other component in a circuit. And in order to understand how it behaves, we need to think about the way charges move through the circuit. So if we connect two capacitors like this in series, I hope you can agree that as the current flows, as the electrons flow, this one here can charge up, and this one here can charge up. This one here can get a negative charge, and this one here can get a positive charge. But on the inside, they're just moving in response to the outer plates getting charged up. Okay, the net result of that is that the capacitance, the total capacitance in the circuit, is going to be determined by the way it charges up. And we find that the total capacitance is calculated reciprocally. Okay, 1 over the total capacitance equals 1 over the first capacitance plus 1 over the second capacitance, and so on for however many capacitors there are. And we can figure that out by just looking at the way the charges behave around the circuit. Okay, and we can derive that from Kirchhoff's law, and if you're interested in that, I can demonstrate it in class. But for our purposes, we don't need to derive this. You won't be asked about it. I can do it if you're interested. Parallel circuits, on the other hand, work slightly differently. So we've still got our power supply, and we've got one capacitor there, and we've got our other capacitor here. Okay, C1 and C2. And in this case, I hope you can see that the charges will run across and charge this one, and they'll charge them independently. They'll be able to flow independently through that. So when we add together, when we look at this in terms of voltages, we can see that the voltages across this are going to have to be equal. And when we do that derivation, it works out that the total capacitance is C1 plus C2. Again, as with the series circuit, I'm happy to show you that derivation, but you don't need to know why that's the case or know how to derive that or demonstrate that. You just have to be able to apply it. So if you are interested in finding out about it, we'll do it in class. That's pretty much all you need to be able to solve capacitor problems.